Correlation and regression is the topic for this particular video. First, we have correlation. What is correlation? Correlation is the relationship between two quantitative variables such that change in one of those variables affects the other variable. Let me give you an example. For example, so I have a person right here. This person has his own height and his own weight. When height of this person increases, there's a higher probability that weight increases as well. What has happened in this condition? In this condition, we have two quantitative variables, height and weight of a person, and we were able to establish a relationship. That is, when height increased, weight increased as well. Such a relation between two quantitative variables is what we call correlation. So what is correlation? It is a relationship between two quantitative variables like height and weight of a person such that change in one variable affects the other. When height increased, weight increased as well. So the example is relationship between height and weight of a person. Mathematically, there is a term called coefficient of correlation, and coefficient of correlation is denoted by small r. What you need to know is that coefficient of correlation is always less than equals to +1 and greater than equals to -1. So r lies within the range of -1 to +1. You will come to know more about it soon enough. But for now, you need to understand what is correlation and what's the range of coefficient of correlation. Another concept. So in my video of statistical graphs, I said that the graph used to show relationship between two different quantitative variable is scatter diagram. So in order to show correlation between two different quantitative variables as well, we are going to use scatter diagram. So the statistical graph that I'm going to use throughout this video is going to be your scatter diagram. Okay. Final, fourth concept. Correlation, relationship between two quantitative variables. There are altogether three different types of correlation that we are going to see. Positive correlation, negative correlation, and absolutely no correlation. So first we have positive correlation. So correlation is what? It's a relationship between two quantitative variables where the change in one variable affects another variable. Which statistical graph is used to show relationship between two quantitative variables? Scatter diagram is used. So which statistical graph are we going to use now to show correlation? Obviously, your scatter diagram. So here I have a scatter diagram with x and y axis, On x axis, I have height. On y axis, I have weight. Let's say I plot a dot for respective height and weight of a person, and it comes out to be this much. That is, there is a person with height this much and respective weight this much. Similarly, I plot dot for many other people in the sample. If I use a single line to represent all of these dots, it will come out to be something like this. In this case, the slope of the graph is positive. That's why this is positive correlation. Or in layman terms, when x-axis variable increases, y-axis variable also increases. Or when height increases, weight increases as well. That is why it is a positive correlation. That is, x is directly proportional to y. So when x increases, y increases as well. In this particular condition, the coefficient of correlation, that is small r, is less than equals to plus 1 but greater than 0. So it lies within the range of 0 to plus 1. Now, either the correlation between two variables can be perfectly positive or moderately positive. So we have number A, perfectly positive correlation. So here's the scatter diagram for perfectly positive correlation. Okay, that's not an axis. Okay, here it is. So there's your x-axis and y-axis. Let's say on x-axis I have school marks and on y-axis I have university marks. I plot dots for different students with their respective school marks and university marks. And when I join those dots or represent those dots with the help of a single line, it comes out to be something like this. In this particular condition, the correlation is positive because x is directly proportional to y. But then that's not it. The positive correlation is also perfect because x and y, they fully correlate. What does that mean? It means that when on x-axis the value increases by 1, on y-axis value increases by 1 as well. That is why it is perfectly correlated, or there is perfectly positive correlation. In this case, the coefficient of correlation is equals to plus 1, and that's the maximum value for coefficient of correlation. Second is moderately positive correlation. So here as well, I have two axes, x-axis and y-axis. On x-axis, let's say I have age of wife, and on y-axis I have age of husband. Upon plotting the age of wife and their husband, it comes out to be something like this. Upon drawing a straight line that represent these dots, it comes out to be something like this. So in this case as well, when the value in the x-axis increases, the value in the y-axis also increases. So it is positively correlated. That is, x is directly proportional to y. But then it is not fully correlated, or it is not in proportion. Not in proportion. X is directly proportional to y, sure, but then it is not in proportion. That is, when x increases by 1, y does not increase by 1. X might increase by 1 and y might just increase by 0.2. So there is no perfect correlation between two different variables. Even though it is positively correlated, that is when one variable, that is variable in x-axis, increases, another variable, that is variable in y-axis, also increases, but then they don't increase equally. There is no equal proportion between the two. That is why it is moderately positive correlation. In this particular condition, the coefficient of correlation is less than plus 1. It is not equal to plus 1. It is never equal to plus 1 because it is moderately positive correlation, but greater than 0. Okay. Second, we have negative correlation. Example of negative correlation. So I have the two axes, x-axis and y-axis. On x-axis, I put vitamin C intake, and on y-axis, I put prevalence of scurvy. Scurvy. Okay. When I plot dots for people who have vitamin C intake and the respective prevalence of scurvy, it comes out to be something like this. And if I draw a single line to represent all of them, it comes out to be something like this. In this condition, x is inversely proportional to y, and that is why this particular diagram shows, or graph shows, a negative correlation. This is what it is showing. When vitamin C intake has increased, the prevalence of scurvy or the possibility of getting scurvy has decreased. So vitamin C intake increases, the case of scurvy decreases. There's a person who has plenty of vitamin C intake, so he has less chance of getting scurvy as well. So this is how negative correlation is seen. In negative correlation, coefficient of correlation is less than 0, but then it can be more than or equals to -1. Again, either it can be perfectly negative correlation or moderately negative correlation. So number A, that's your perfect negative correlation. On x-axis, we have volume. On y-axis, we have pressure. So if we draw a scatter diagram between these two variables, the graph comes out to be something like this. So as you can see, when volume increases, pressure decreases. So x is inversely proportional to y, and that is why it is negatively correlated. But it is perfect negative correlation, because when volume increases by 1, pressure decreases by -1. So they are in proportion. So when volume increases by 1, proportionally pressure decreases by -1. In this case, coefficient of correlation R is exactly equals to -1. Second is moderately negative correlation. So we have two axes, x and y. On x, there's economic condition. On y, there's case of tuberculosis. The scatter diagram comes out to be something like this. In this case as well, x is inversely proportional to y. That is, when economic condition becomes better, the cases of tuberculosis decreases. So they are inversely proportional. That is why there is negative correlation between the case of tuberculosis and economic condition. But then it is not perfectly negative. It is moderately negative, because when economic condition improves by 1, the tuberculosis case, it decreases by 0.2. Since they are not in proportion, it is moderately negative correlation. There is no perfect correlation between economic condition and tuberculosis. But we know this much, that it is true that when economic condition increases, tuberculosis case or the probability of getting tuberculosis decreases as well. Then we have third and final type of correlation, and that is no correlation or absolutely no correlation. You might have already guessed, in this condition, there is no relationship between two variables. So on x-axis, we have salary, and on y-axis, we have baldness. Upon plotting diagram of people with their respective salary and the presence of hair in their head, the graph comes out to be something like this. So here, x is not dependent on of y. So it doesn't matter how much salary a person has, that does not affect the condition of his hair. That is, the person might be bald even if he is poor, or he might be bald even if he is rich. So here there is absolutely no relation between the two variables. That's why we call it absolutely no correlation. In this particular situation, coefficient of correlation is equals to 0. So that's it for the various types of correlation. Next topic is regression. Regression is a statistical technique that relates a dependent variable with other independent variables. Under correlation, I said that an increase in weight is explained by an increase in height. That is, when height increases, there's a probability that weight increases as well. But then weight is not just dependent on height. There are other factors as well that influence weight. The explanation about all these factors influencing your weight is given by regression. For example, here's your weight. Weight is dependent on various factors like height, calorie intake, exercise. An increase in weight can be explained by an increase in height. An increase in weight can be explained by an increase in calorie intake. An increase in weight can be explained by a decrease in exercise. So here the weight is dependent on various other factors. That's why weight is your dependent variables. However, those factors that the weight is dependent on are independent variables. They, on the other hand, are independent variables. The reason being they are not dependent on weight. Your height is not dependent on weight. How much you eat is not necessarily dependent on your weight. How much you exercise is also not necessarily dependent on your weight. What regression does is that it gives you the answer to the question, what percentage of an increase in weight is explained? What percentage of increase in weight is unexplained? Again, let me make the thing much more clear. Let's say you take a person for study. This person is Ram. You study about his weight and the fact that his weight has increased. You study that the increase in Ram's weight has been due to increase in his height or increase in his calorie intake or decrease in his exercise. So you can use these various factors to explain the increase in his weight. And then quantify what percentage of increase in his weight is dependent on height, what percentage on increase in weight is dependent on his calorie intake, what percentage of increase in weight is dependent on his exercise, and there will be few percentage of increase in his weight that has no explanation because you haven't studied it yet. There are other factors that you have not studied or you don't know about that has influenced his weight. So the answer to all these questions or the quantification of the factor influencing weight is done by regression. Mathematically, regression is represented by the equation y equals to a plus bx, which is similar to the equation y equals to mx plus c from school days. So in this case, in this particular equation, y represents your dependent variable like weight in previous example. X represents the independent variable. So there were many independent variables that was taken under the study. You can take any one of them. For example, it can be height in this case. So you have taken height among various factors. A is a constant and B is what you call the regression coefficient. So if you learnt in maths, you might have already known the graph for y equals to mx plus c. So the same graph is going to be here as well because the equation is similar to y equals to mx plus c. And it can be produced backward. Okay. In this particular graph, the slope of the graph is your b and it's your coefficient of regression. Okay. Correlation coefficient is denoted by small r. When you square this small r, you get r square. And r square is what you call the coefficient of determination. Coefficient of determination is important because coefficient of determination tells you what percentage change in dependent variable can be explained by change in independent variable. Okay, what does this even mean? Let me tell you. So let's say you are studying a certain person. You are studying the weight of this person. You observe that the weight of the person increases. You find out the various factors influencing the weight of this person. Among those factors, you choose the height of the person. You see that weight of the person has increased because the height of the person has increased. So height is one of the factors that you are using to relate with the weight of the person. In this case, weight is obviously the dependent variable because it is dependent on height. But height is independent variable because it is not dependent on weight. Now, what coefficient of determination does is that it explains what percentage of increase in weight is explained by increase in height. So there's your person. The weight of the person has increased due to increase in height. Now coefficient of determination tells you what percentage of increase in weight of this person is explained by increase in height, and obviously the remaining percentage gives remaining percentage tells you that there are other factors responsible for the increase in weight, which is unexplained under the study. For example for example let's say coefficient of correlation between height and weight of a person is equals to positive 0.3. This means that height of the person increased by 1 unit, so the weight of the person increased by 0.3 units. What is coefficient of determination? Coefficient of determination equals to r square plus 0.3 square or plus 0.90 or 90 by 100 or 90%. So what does 90% mean? It means that 90% increase in weight of a person can be explained by increase in height of that person. The remaining 10% increase in weight of that person depends on some other factors that we don't know of. So when height of the person increases by 1 unit, the weight of the person increases by 0.3 unit. In this case, the coefficient of determination comes out to be 90%, which means that 90% of increase in weight of that person is explained by the increase in height of that person. The remaining 10% of increase in weight of that person is not explained by increase in height of the person. It is explained by some other factors, and we have not taken these other factors under our study, so we don't know about them.